Hey everyone, welcome to a quick session of getting started with Firebolt using Jupyter. Let's get started. So today we would like to take a look at how to query some data and metadata from Firebolt using Jupyter. We could do most of this with the SQL workspace in Firebolt as well, but using Jupyter has a couple of benefits like being able to graph some statistics out. So before we do this, a quick reminder of what the dataset is like. I tend to use the GitHub Archive, which is basically a list of public events happening on GitHub, which is completely archived since 2015. This is indexed into Firebolt, and this is the basic dataset that we're going to use for querying. Also, we use the Firebolt Python SDK for this. So in order to get up and running, this needs to be installed. Let's take a quick look of how this is done. And basically I use pipenv here, have a pip file with the dependencies listed, and that's about it. Taking a look at this pip file, you'll see that the Firebolt SDK is used, that Jupyter is included, and matplotlib because we want to draw some graphs. And we can just run this with pipenv run Jupyter notebook, and everything starts automatically with the dependencies downloaded properly. So once we have done this, we can take a look at Jupyter itself. The first step is the initialization and the importing of packages. So when we take a look here, we are going to use matplotlib. We need some operating system packages and of course the Firebolt package. All the credentials and the endpoints are read from the environment. So this is exposed before Jupyter is started. Then a connection is created and then we can use the cursor to execute all the queries. So once we do this, we can run this piece of code and see that the connection is not closed, so a successful connection to Firebolt has been created. First thing that we can do is run select now, so we see that everything is up and running. You see here that the Firebolt SDK automatically convert this into a datetime type, which represents the current time. Second step we can do is just count the number of events. So once we do this, we see there's a little more than 5 billion events in the dataset. And we can now query further details about it. And the next two queries we're going to run is the number of distinct repositories involved, as well as the number of distinct users. So we see that in this setup, we have roughly 276 million repositories being involved and 51 million users are acting on it. Also, we may want to take a look at how old the span of the data set. So we take a look at the min and max created at timestamps, and we see here this starts in 2015 and ends in 2022. Again, to get another overview over this, we can just query by the year and the number of events. So we get the number of events for every year. You can see here for 2015 up to 2022. However, that doesn't really help us as we humans are not the world's best number parsers. So what we could do is we could use matplotlib to actually draw this. So let's do this, and we see here that over the years there has been a steep increase in GitHub events happening publicly. And I think around 2018 GitHub got bought by Microsoft, so maybe they helped a little with increasing activity on the platform. Of course, this is very, very coarse. We could just get one number per year. Maybe we can go further and get a number per day. So running this and graphing this will show the number of events on a daily base, which means just from here to here, we will have about 365 events. And you can see here, it's clearly rather dense at this position. So what we would need to do is maybe creating a moving average of those events to see how they behave over time and smoothen this line out a little. So once we do this and we run this, you can see here everything here can be done completely in SQL. We create a moving average between the current row and the 21 days before that, so around 3 weeks. And graphing this now shows a way better line that's just easier to read from a human perspective. And you can also see that there's now a couple of trends popping up. So at the end of every year, there is basically a dip, which probably is a New Year's or Christmas Eve and New Year's dip. Then there's usually a sharp uptake, which happens as well. We have another Christmas dip over here. This is actually not a Christmas dip, but just a missing data. The Christmas dip or New Year's dip is over here. So this basically happens all the time. This makes it much more readable. So what we can do next is figuring out what our query is actually querying. Like, how do we return the counts of 5 billion events so fast in Firebolt? So what we can do is we can run an explain on the query we just executed. Let's do that. And that explain is a little lengthy. You can see here the different, the windowing function, the projection, predicates and aggregates. But the interesting part is the data structure we run this query against. And this is not the GitHub Archive table, but it actually is an aggregated index called account date filter. And we will see in a second what this actually means, because now we can take a look at the metadata from the GitHub Archive index. Once we do this, we could run the information about the tables. So what you usually run with using show tables, but running this against the information schema table means we can actually filter by tables, which is really useful if you have lots of different tables in there. And we would see here that we have a fact table. We would also see the complete DDL used to create the table. So we can basically take a look in the past, what has been done there. So that's really nice. But it doesn't really help us to figure out what this index is looking like. In order to do so, we could either run show indexes, or we can take a look at the information schema indexes table and run it from there. And then we can finally take a look at what the magic behind this is. And this is basically that there's a so-called aggregated index, which contains the definitions that you specified on creation. And in this example, we basically store for each day the count of events already upfront as part of this data structure. So this gets created when data gets indexed. And all you need to do instead of scanning the whole table is now basically just looking up in this data structure what the count for each day is and then returning it. And that's one of the tricks why this particular query was really, really fast despite the number of documents involved. And when we take a look at the different kind of indices used, there's always a primary index in every fact table, but there's also the aggregating index that you just used. And using these aggregating indices, we can also make queries like the distinct count that you saw earlier much faster, because we can just pre-populate this data. So I hope that gave you a quick first overview over querying data with Firebolt, using Jupyter for this, because not only you can use graphs for this, but you can also use pandas or NumPy for this. You could also combine this with Python libraries for time series anomaly detection if you wanted. So the moment you run code in Jupyter, the possibilities of what you can do on top of the data once you extracted it out of Firebolt are really, really interesting. And the same obviously applies when you start to index data using Firebolt, that you just keep re-indexing the data that you may have generated from models. That's it for today. The last thing we have to do is basically closing our connection. So we have to make sure that the connection is properly closed once our queries are done, just to make sure we don't use any resources locally or remote. That's it for today. Thank you and have fun using Jupyter.